Welcome to this tutorial. In this tutorial I will show you the basic concept in TranAX regarding experiments, data storing, measurement flow control and how to reload measurement files. Let's start with the experiments. I like to show you what is behind the concept of the experiments and what is the best way to use them. I started already TranAX, and as you can see in my recent experiment, you see already my last experiment I've used, it was the demo 1 with this experiment set demo 1, which is a zip file. So let's have a look how it looks like on your hard drive. I'm now in the document folder where TranAX the experiment stores by default. And you see here the demo experiment as shown here in the last experiment. This is actually a normal folder with an extension X, but actually it's a normal folder. You can go into, and here you see the basic structure of an experiment. So you have this zip file. In the zip file, all settings of your software and also of your hardware are stored. So you have several files. For example, here the lay file is the layout. You have the MFC for measurement flow control. The TPS is actually the hardware settings, and there's also a picture which is normally the snapshot of your last settings. In one experiment you can have several experiment sets. For example, if you have several settings which must be used, but they are linked together because, for example, it's the same setup. So you can use one experiment with several experiment sets, or you can use one experiment per measurement. Also, by default, there are some folders. It's a data folder where normally the TPC5 file should be stored. In the expression folder, now it is empty. The formal editor is storing all the calculated file, and the CAN folder actually is not used at the moment. So let's switch back to the software. So I can open either the last experiment, or I can say, okay, open experiment. I choose this folder and I choose the experiment set, and you get the software in the state you have left with these settings. Important thing to know is normally if I change something in my settings, for example, I add a new waveform here for a second channel, and then I close the software and reopen it again. I open the demo experiment, and as you can see, the last change, so the extra waveform, was also stored in these settings. This is important to know, that normally every change in your settings are stored automatically in your experiment set. So if you think, okay, that's not the way I want to work, so I want to keep my settings forever, for example, so I remove this and say, okay, this is my default experiment set that I want to keep. I turn on here this write protection. I say yes. So write protection means that every change that I'm doing now will not be saved in the experiment set. So for example, if I remove this waveform now here, I can remove the scalar table here, and then I close the software, reopen the experiment again, and as you can see, the experiment is back in the state like before I turned on this write protection. What you can do now is to copy your experiment to use it for another test, and so you have a master experiment reusable for other people also. I have to close the software, otherwise the experiment set is blocked, so I close it. and I make a simple copy and say, okay, this is my test 100. Important things, you have to type .x. I then go back to the software. I open the new experiment, the test 100. The experiment set has still the same name, but it is in another path. And now you can do your test. And as you can see in the top, you are in this new experiment. And of course you can also remove the write protection, because actually you have protected your master experiment. Another thing to do is using your master experiment as a template. If you click on new experiment, you see here a list of templates. This list actually is located on your hard drive in this path, in this default path. You can change this also in the settings. But as you can see here, these experiment set zip files. So one thing to do, for example, is to take my demo1 zip and copy here to this path. And you see now here I have my demo experiment as a template here, and I can generate a new experiment based on this experiment set. So my test 200. So you have created here a new experiment, test 200, and it is based on this template here in your template folder. You can also organize these templates in a structure, so I create a new folder here, and I could say, okay, else is base experiments, and copy all this in this folder, and make here my own experiments. Copy the demo one in this folder. If I create and make here a new experiment, you see you have this organization also. Next, I like to show you the concept of storing data to the hard drive and to reload it in TranAX. So if this is my measurement, I like to save it in a TPC5 file. I go through store data, save, and then I say, okay, I only want to have channel 1 here. I say, okay, I want to save everything, and then I click OK. I can give it a name, data 1. So, how to reload that? For this we need this signal source browser, and we are here in the experiment view, and I see here my experiment and here the data folder, and as you can see here it just created the file is visible here with one channel in it. So for reload it, I make a new layout, a new waveform, and then I drag and drop my channel here, and as you can see here the data are coming from the file. So I can make a new measurement, for example, save, store that, do the file, I keep these settings, say data 2, and you see here my second channel. I can drag and drop it also in the same waveform. No, not in this one, in this, delete. Okay, so I have my two files here. Next, I like to show you the concept of references. So what's the goal behind this concept? Actually, if you have a measurement with 8 channels, for example. I have here prepared my waveform. I've prepared here also already a scalar table to make a new measurement, so everything gets updated. And I've stored some of the measurement to a file. You see it here in the signal source browser. I have my data 1 and 2. And so now I want to compare my measurement from this hardware configuration to the data from the file. So I don't want to configure my waveform again, my scalar table again. And for this case, it is useful to use the references. So if you are in the signal source browser, you see this tab on the right side. You can open it and you see here some fields. What we do now is saying, okay, I have my reference 1. I configured the reference 1 with my data from the hardware. So I drag and drop my hardware here in the reference 1. In the waveform, I remove the hardware channel, drag and drop the references in my waveform. If I start a new measurement, I see that the data get updated, but they are linked through the references, as you can see it also in the label description. For linking the scalar table also to the references, I have to drag and drop the reference traces from the waveform to the table. And now if I want to compare it with my previous measurement from the file, I go here in my experiment folder and I drag and drop my file in my references. I have the same number of channels here in my reference. I drag and drop this here and you see I get updated my waveform. It's coming now from data 1 and also the same here in the scalar table. It has updated the trace source to my reference. And so I can go to my second file and everything gets updated. So it makes it much easier to prepare something which you can look at during the measurement. But then if you have saved your data to a file, you can use the same experiment and have a look at your files through the references. If you want to switch back to the hardware, you go back here, data, and say, okay, this is my hardware. And so you have your channel again linked to your hardware. You can also configure a reference with only one channel inside. So you can say, okay, reference 2 is only channel 1. That's also possible, but then you have also to change from only one channel here. So if you want to replace a file with several channels, it's easier to have all the channels in one reference. To have a look what is inside your reference, you can go here in the reference tab and you see my reference 1 has 8 channels here and reference 2 has only 1 channel here. What you can do also with your reference is to assign a post-processing task here to a signal. So for example, you can say, okay, I want to get rid of this ripple here. I say here low pass filter, and for example I say here at 1 kHz low pass filter, and then you see I've get already this filter signal, and here it's noted that this is a processed data. And if you want to have it also here in your scalar table, you have to update here because this has changed to the processed one. So that's why it was assigned again. But now you can make a new measurement and it is filtered automatically. So there are some low pass filters here. There's also a median filter, for example. Say, okay, median 100 samples. And you get another filter type here. Another way to store data to the hard drive and reload it back is to use the store page function. So it is here in the store data, you see this save page. A page is actually what you have here in one page. So I have here two waveforms and I have here a scalar table. So I go to Save Page. I give here a name, Page Data. And I say include the data of page 1 and say save. Then I can say okay, reload the page. And this has created now a new page with exact the same data and the scalar table as before. So here is the measurement from the hardware, and this is the page from the file. So it has updated all the link to the data, and all traces are stored in one file. We have seen that if you are working with scope and multi-block mode, you have to store the measurement data to a file over the store data menu. But what's happened if you are using continuous mode? So if I start a measurement here, actually the data are already stored to the internal hard drive of your TranAX FE device. So basically you can also use this data directly instead of storing the data to a file. I will show you how to do that. If you have opened the single source browser and you are connected to the device, you see here in the data ribbon an icon for your device. If you click on that, it will open a file explorer connected to your network drive of your TranAX FE device, and you see here these PDF files. Normally there are stored several files on the disk until it gets deleted, the latest one. So I can open the latest from just what you have generated and can open it here, and you can open the file here with this plus icon to see which channel are stored in this PDF file, and can open it directly. But keep in mind, if you have a big measurement, it could take a while. Often it's better to copy the file to your hard drive first and then to open it directly. Another way to get your files is over the website of the device. If you click in the control panel on this info icon, you see here website. This will open the browser with the IP address of your device, and you see here the file explorer, and you see exactly the same files, and then you can download it from there and open it in TranAX. Perhaps one way to open files is by drag and drop from the explorer. So it is also possible to drag a file directly here. It could be a TPC5 file, it could also be a PDF file, or you can also open the page file directly here and you can visualize it directly. Now we want to make a measurement report out of your data. For this we are using the documentation page. You can create a new documentation page by going in the layout ribbon and say here documentation, and this will create you this new page. I will close the control panel, and I also don't need the single source browser. So this is like a sheet of paper, and you can place here elements on it by just drawing. You can place different waveforms, you can place the scalar table. You can also draw lines and rectangles. You can place some text. And you can also place images here, for example, for placing your company logo. Now we are in the design mode of the documentation page. If you switch back to the preview, you'll see how it would look like if you print it out. For bringing in the curves, you can go either in the single source browser and drag and drop if you want to make it out from hardware, or you can also use the single source browser and say okay, take it from my PDF file. You can zoom in. If you go to preview, you can see your data in the print layout. Another way to create a new documentation page is by make a copy of your already existing page. You click right on this icon and then create documentation page, and this will copy actually the same waveform, the same data, and already configured your your scalar table. But changing here black to white, you will make a right click and say white background here. If you are done, you can say print and then select, for example, the ELSYS PDF printer for generating PDF out from your page. In our example, we have here a 20-second measurement, and actually I want to split that on several pages for a report. So how to do that? I say here split time, set it to true, and I set my split interval to 5 seconds, which gives me about 4 pages for these 20 seconds. And then I add several pages. And as you can see on the axis, this will split my measurement in 5 seconds blocks.